Hello, good day, everybody. As always, we will be waiting for around 5 minutes to let some more people enter um, to see if we get some more people here. That always happens in the first 5 minutes. So we'll wait for that and then we'll get started. Hello, everybody. Let's see if Pablo's.
Yes, I am.
Yes,
Okay.
there he is. Wonderful. All right. Thank you all for being here. We have a nice big group today, which is always exciting for us. So let's get to it. Thank you for being here. So, for this webinar, we have, as always, myself hosting it, taking your questions and guiding us through the webinar. We have Jesse van Dongen, who you saw last month, I believe, on your screen. He's now behind his screen and he will be moderating this webinar, and he will also be in the chat to answer any questions you might have. We have invited Pablo Pozo this time to talk to us about our material and about the importance of material in general and about 3D printing. So we are excited to get his expertise on here. Pablo, if you could introduce yourself.
Yes. So, hi everyone. I'm Pablo. I'm the structural engineer of CyBe, and later on in this webinar, we're gonna talk about a little bit about 3D concrete printing, the benefits, the main things that you should understand before getting into 3D concrete printing. So, it's supposed to be a very fun webinar for today.
All right, brilliant. Thank you, Pozo. Pablo, we look forward to it. Um, So a lot of you have been here before. I just checked the emails, so I know, but a lot of you are new. So let me explain what this webinar is, why we do it, and what the format is. So the one you are looking at right now is, of course, live, which is why the live chat works. But we also have these webinars on demand, meaning that you can find them on our website if you missed one or you want to look back at one to get some more information, or on YouTube as well. Like I just said, if you have any questions, ask them in the chat, and yes, myself or Pablo, depending who's speaking, will answer them. If your question doesn't get answered immediately in the chat, it might mean that the answer is a bit longer than just a chat message, which means that we will address it at the end of the webinar verbally. So the current subject of today's webinar is going to be discovering the future of 3D concrete printing, exploring CyBe construction. So our materials and our way of local material development. And Pablo knows a lot about this because he's also responsible for the local material development that we do with our customers, or part of his responsibilities are that. Next month, we are looking to invite a partner of us, Fazarian, onto the podcast. We expect that to happen, but we will confirm. So check your email, because we always invite and confirm all of you to these webinars. The month after that, we have something planned. Also, we're not sure if that's going to happen, because we might have a surprise webinar coming in between those. So again, check your inbox, and yes, we'll let you know what we have waiting for you. So, like Paolo said, today's webinar is going to be about what is concrete printing. A lot of you already know, but also what are the benefits and why should you use it, right? Then we're going to talk about materials specifically. So what makes a 3D concrete printing concrete mixture so unique? How does it comply with sustainable development goals, as it is concrete, and everyone knows that concrete doesn't have the best of names in the sustainability department. So we'll talk a little bit about how we figure that out. And how do we provide local material solutions for our customers? And Pablo will talk about that as well. So a lot of you know we like to work with polls to make it a bit more interactive, to get some information for you, and to just test the waters on where everyone's at. So we would love to know how you got to know about us as a company. And I believe if you look on the bottom or the side of the webinar, you should be able to fill out that poll. We have some options right there. Yeah, Google still effective these days. Research articles. Oh, that's interesting.
You forgot about the ChatGPT.
Yeah, ChatGPT. Yeah, that might. I wonder if we show up there.
I'm wondering if our viral video in TikTok brought some people here.
Yeah. because there's one TikTok video that kind of did all right, so to put it, but I don't think our targeted audience is very active on TikTok, to be honest. So, but you never know. You never know. So googling a lot. That's great to hear, because we came to the conclusion that we're not so much a marketing company, we're more a construction company. Just so hearing that we show up quite well in Google, or at least that some people were able to find us using Google, that's great to hear. See, and LinkedIn, of course. Yeah, brilliant. All right, thank you guys very much. It's lovely to know. I would like to start off a little bit with the background of CyBe, and a lot of people that have viewed our webinars before already know this, but there's a lot of new people, so the background is important to understand why the material is so important. So our mission for the company is being the global innovator, the leading global innovator, in a mission to build more affordable, more faster, and more sustainable. And we do this by internally, in-house developing software, hardware, and of course the material, which we do with our partners, but we're very active in this development as well. The vision is that we believe that the only way that we can tackle different problems that are visible in the construction industry worldwide is by doing it globally and holistically. So looking at all the different aspects of the problems and getting a nice holistic solution to this. That's our vision. Then how do we achieve this mission? Like I just said, we like to build faster, more affordable, and more sustainable. It sounds good on paper. Everyone wants to do that, of course. But the question is, how do we do that? And the building faster part has a lot to do with the material. So the printing speed that we can establish is very high. Our material dries very quickly, so we can hoist our elements after 24 hours. It dehydrates really quickly, which is why we can work on the printed part pretty much the same day or the day after. More affordable in the construction industry, as a lot of you know, time is money. It's a cliche, but it's definitely true. So by being so much faster, we can decrease the construction costs quite a lot. Also because of less labor, because we integrate the solutions, and because we can build more houses in the same time, the turnover increases, which makes the overall project, of course, less expensive, so more affordable. Sustainability, I think Paolo will talk about this quite a bit, but we do produce quite a bit less CO2 with our material. Of course, because we're printing it, we waste a lot less material, and we use less material in general because of how we print with a very narrow print path. So we don't do this alone. Like I said, we want to do this globally and holistically. So we work with partners around the globe. A lot of you might have seen this picture before, but we put it back up here for the people that didn't. But as you can see, we work with partners worldwide. One of them is Corox in New Zealand, who just finished a very exciting project. I believe it was a kindergarten is the way that we put it. So that's super exciting, and this will also probably be a bit the topic of the surprise webinar that we might have. Not such a surprise anymore, indeed. But so we will see if we can get Wafi from Corox, one of our partners, on the webinar to talk about this project and to see if we can share a bit more information about it and how we experience working with our machine and our material to make this happen. So that's quite exciting. Then another poll, just to see at what level you think you are in the material knowledge. According to you, what is your knowledge of materials for 3D concrete printing? Expert. I like that. Someone is very confident.
We have a lot of advanced beginners. That's nice.
Yep. That's great. I like how Jesse put competent in there. I would select that one anyways. Right? let's see, proficient. Yeah. So a lot of advanced beginners, as Paolo said, which is great. That means that we can teach you a lot. Experts are very hard to teach something. So no, that's great. Thank you, guys. And I believe Pablo will now share with us some of his knowledge.
Okay, good. Ready? So now that we know the distribution of the audience that we have, we would like to refresh the minds of the people who have already a high level, like the experts, and also to explain a little bit to the people who are just getting into, like the beginners. So everybody in this webinar can be almost at the same level, at least in the basis of 3D concrete printing. So let's continue. So when my friends ask me, what do you do in your company with 3D concrete printing? I try to explain to them that 3D concrete printing is just like the 3D printing of PLA that they have in their homes, with a little detail that is in a way larger scale, and also with a more sensitive material because we are working with concrete. Can you play the video?
Yeah,
Yep.
already I've seen that.
Yeah, just
Okay.
put them on.
So basically, as you can see in the video, the machine it deposits the cementitious material in the way that we planned it in the beam design. So this allowed us to have a high precision and also a very allowed us to have very complex designs. And these are some of the few benefits that we have from 3D concrete printing. For example, one that comes to my mind is the high precision one, because since we are using heavily beam, the machine, and we are using robots, the machine deposits the material exactly where we want it, and we can obtain a very high quality and also very complex shapes. For example, if you see the second picture, you can see a very nice finishing, because first we print, and while we are printing, we can polish that part in order to have this kind of finishing. Also, as I said, since we use robots, robots tend to do less errors than us. So fewer errors means better performance. And better performance means a cheaper total cost. Another really important part about 3D concrete printing is the efficient use of materials. Since in traditional construction we are constrained to the shapes of the formwork, with 3D concrete printing we just deposit the right amount of material that is necessary. If you check the photo that I put there, this is part of the research of topological optimization. That, in other words, is the mathematical method that optimizes the localization of the material, depending of the purpose, loads, or boundary conditions. This means that we can design, in this case, a chair, a table, or important structural element, and just deposit just the right amount of material. And in this way, we are saving a lot of material. We are using the material in an efficient way. There is no phone work, so we are not using that part of the materials that are normally used in construction. You have to bear in mind that phone work, it seems to be not important. It seems to be that it's not an important element in constructions, but normally in traditional construction, phone work tends to be 20 to 30% of the total cost of concrete construction.
So, and that's not just for very complex shapes like this, but also for general walls. If you have a simple, quote unquote, simple curved wall, a custom radius, for example, or a double curved wall even, then formwork becomes very complicated and expensive very quickly. So, of course, this is a very extreme example, but even just for walls, what Pablo just told still applies, right?
Yeah. Next. So as Dan was saying, since we're not using formwork, the formwork normally is used 1, 2, or 3 times depending on the material. So in this case, we are saving that part in cost and also in materials. And for example, if you check both pictures, on the left we have a very bad construction site, say, and on the right we have the construction site for a 3D concrete printing. And normally in construction sites, you can see that there are many materials, they are damaged, they just became waste, or they they just don't work. So, but in 3D concrete printing, we have to have the opposite, because since the material is quite sensitive, everything has to be very organized and very well planned. So the total environment is changed. Also, one of the problems of the traditional construction is the difficulty of tracking the materials efficiently. And with 3D concrete printing, since we are used just a robot that is putting all the materials, is much easier. And also because we are using with BIM, this allows BIM, for the people who doesn't know, I just kept saying BIM, just assuming that people know.
Yeah.
BIM is building information modeling. So it's the digital model that architects, structural engineers have. And in this way, working with BIM and 3D concrete printing allows to a better communication between professionals in all the areas and processes of construction. Also, it allows a better cost estimation.
Yeah. As always, we somewhere around the 20-minute mark, we get a notification from our webinar supplier that the internet connection is bad and that we need to put an internet cable in there. We don't trust them, but could you let us know if the connection is still good, if you guys can still see us and hear us?
But I received a question in the chat about the image of the previous slide. And the question was from Garrett: did you print the slab or on the left, or is it the one from Zurich?
No, that's the one from Zurich, but it depends on we are able to do that kind of designs. That's why I wanted to exemplify that. Zurich, in this case, they didn't use formwork, so it's possible to do this. But if a client requires this, we are happy to do that.
Yes, thank you. And it seems that the internet is good and stable. So
Good, perfect.
Okay,
Then
good.
we can
Thank
continue.
Continue to the other one. So as we already said, we are saving material, we are saving also, we are having less waste, but also in a construction site, you can see that a lot of people are working in just one building. But we are happy to say that for a small, of course, this depends a lot in the complexity of the construction, the how long is the project, but with, for example, a wall with the technology that CyBe uses, we only need 2 or 3 people for a safe and successful print. As you can see in the video, we just we just need one person using the machine, while other person is providing the cement to the mixing. Just to put you just to give you a perception of like how many people you need, or how also in the time that is needed to print. For, let's say, a wall that is 4 meters long, 3 meters high, because Dutch people are quite tall, and two-layer system, we need probably a couple of hours. So it's a huge element that it can be done in probably 2 hours. And this allows, as Dan was saying, money is time is money. So we are saving a lot of time there as well. And this can be exemplified with the project we did in Milan, the Housing 05.
Yeah, I can shortly, sorry to interrupt you, shortly answer a question about smoothing the walls. We do that with a wet sponge, which makes it very easy. You can almost get it as flat as normal plaster, depending on your skill with the sponge, but you can get it pretty much as smooth as plaster, I believe. Yep.
So in the Housing 05, the printing time was 35 hours, which is crazy to see that all of those elements were printing in 35 hours. Although you have to bear in mind that the whole project, the finishing, the also the things that are inside. It took in total a week, but to have these kind of designs in a week is really nice to think about it. So now we're gonna get a little bit more technical, and I want to explain to you what is necessary to obtain a printable material. So developing material, I like to say that it's like cooking. You need to find your recipe that fits you, because in 3D concrete printing there is a large variety of mixes, a large variety of robots. So probably I can develop a mix that can work with CyBe robots, but it might not be efficient or the best way for other robots. So this all depends on the mixer system, the length of the hose, the nozzle, the project. It changes a lot. However, in my experience developing material and from my technical background, I can notice that there are 4 properties that are crucial for to obtain a successful print: open time, buildability, extrudability, and pumpability. And we're gonna review this in the next slide. For example, the open time is actually referring to the working time. The open time is the window in which the material remains the way that we want it. And this is super important because when we are depositing the material layer by layer, if the first layer is already too dry, the second layer is not going to stick properly to the first layer. For example, if you see, I took this picture a couple of weeks ago. The picture on the left is the cross section of one of our walls, and as you can see, there is no differentiation between layers. This means that there is a good bonding strength, and also the material is gonna behave like a whole, like the whole beam, the whole wall is gonna behave like a whole.
And like a monolithic
Exactly.
elements, homogeneous. Yep.
So if we have opening time that is too big, and when the second layer is coming and the first layer is not ready, it's gonna happen what it happened when we were trying with other materials that is on the right picture.
Yeah, I'm happy you said that. So for everyone that looks at this print for the first time, this is not our average print quality. Just
we
just to make sure. Yeah.
It was experiment we were trying with new materials, with other materials. So clearly the second mix didn't have the proper buildability, didn't have the proper strength for the material to resist.
Yep.
Then we have buildability. Buildability is the property that describes the ability of stacking layers without collapsing. So as you saw in the videos, the elements of CyBe, they are supposed to be printed in once. So we have a 3-meter wall. Everything has to be printed continuously. So this means that once the layer deposit, the layer has to maintain the shape and strength until the second layer comes. So, for example, we were trying with another material because we were innovating a lot, and I enjoyed doing these kind of experiments. In this case, everything was going smoothly until the 6th or the 7th layer, and then the layer collapsed. So I had to modify the material in order to have enough strength to support at the end the 3 meters of layers. Then we have pumpability. Pumpability is super crucial because the way that we print it. The material has to go through a delivery system, and so basically the material has to adapt to have a sufficient flowability and low resistance to pumping, so we can ensure that the material is consistent and it has an even flow. So the pumpability depends a lot on an adequate water to cement ratio and the mixture that we put, without the mix getting stuck in the middle. And also, aggregate size is super important because you have to understand that our material is gonna go from the concrete mixer to the pump to the host, to the nozzle, and this means that the mix is going to go through very tight places. So, for example, in our case, for CyBe, we don't use an aggregate size bigger than 3 millimeters, because even coarse aggregates could lead to more friction leads to heat leads to a drier mix. So we prefer to avoid this and avoid that the machine get jumped. Finally, extrudability is the ability of the concrete to be pushed through the printing nozzle that is quite small and keep the desired shape and consistency. The extrudability is super important for the print quality, for the dimensional accuracy, and the structural performance of the element that you can see in the video. Also, if we don't have a good extrudability, the structural performance is not going to be the best one.
Yeah. So it's supposed to keep its shape as soon as it comes out of the nozzle, and that helps, of course, with buildability. So it's a stable, nice, predictable shape when it comes out. So then we can stack it. And this also has a lot to do with pumpability and consistency, of course, because if the mixture is too thick, it won't extrude nicely as well. If it's too thin, it will just run out. So it's all about
the proper proportions.
Yeah, exactly. It's about balance.
So now that we are in the third poll, we would like to know what else would you like to know about the material? Because now we have, if you check our website, we have a library in Academy with a lot of information that it can be helpful for you if you are into, you got interested or you have already planning to go more into the material. You can check our website.
This guy just stole my slide.
Ah.
No, that's fine. I'm kidding, man. That's all good. So yeah, let's see interaction. There we go. The answer is, of course, still yes, I want to. But the question is, what else would you like to know?
We're not done yet.
Yeah, exactly.
And we had some good questions in the chat. Some of them we already answered them in the chat. So thank you for those questions. It's helping us also to get understanding about how you are thinking and what is going into your mind.
Yeah.
So feel free to ask everything in the chat, so we can react live in it or just by a thing in the chat. So thank you for that.
Yeah, this might be a nice point to do some questions just so that they don't bunch up. I see a question: are right angles possible? 90-degree angles are possible, but there's always a radius. As you can imagine, this printer, even if it goes at an exact right angle, it's still a round extrusion nozzle, so there will be some radius to this corner. On the inside, it almost looks exactly like 90 degrees, but the outside is always a little bit rounded. So that, I believe the radius is around 40 millimeters, because that's also the width of our layer. Right, so that makes sense. Let's see, matching mix to local code specifications. Greg, that's a good question. Normally, this we have talked about this before, but I will say that again, that we use the material, our wall elements, as formwork, as lost formwork, in which we cast reinforced concrete. For this casting, we use, of course, a normal concrete, because there's no need to use 3D printing material. So for the structural parts, we adhere to worldwide building codes pretty much.
Demonstrate in the video if you want. So here we have it. The project of France.
There we go. So the video there.
We'll stop it there.
Yep. So that's
Yeah,
lost formwork, where we would then later cast in the material, which helps with the local code. I hope that makes sense.
Yeah, one of the main problems of 3D concrete printing now, since it's a new technology, there is no like Aero codes or IBC codes that can provide a standardized way. But there are many institutions. Actually, we are working with institutions that they can make the standards, we can provide them our experience. But I think soon there's gonna be a lot of codes that they take into account 3D concrete printing in the normal codes.
Exactly. Environmentally friendly materials, Francois. That's an amazing question, which is one that we are working on very hard. We have a couple of partners. A partner that is working on a geopolymer, or actually printing with a geopolymer. I'm not saying that is immediately environmentally friendly, but at least it's CO2 neutral or free. We are working on one as well, and we're always innovating to go to more environmentally friendly materials. That being said, things such as clay or other sort of dirt contraptions, that works if you want to build a hut or a small building, but it's very hard to get clay to comply with building codes worldwide. So concrete, or a form of concrete like a geopolymer, is something that just helps to roll out 3D printing globally, because it's easier to adhere to building codes.
I think with the question of Dinesh, we can go to the next part, because we're gonna talk about what Dinesh is saying. It's asking.
Perfect, then let's continue.
Close the chat.
Okay, so now that we understand the theory, a little bit the theory behind the workable material, we can show how the CyBe mortar achieves all the properties that we mentioned in order to get the quality that we have seen in the videos. For example, and because of the speed of a robot that, as Dan mentioned, is about 500 millimeters per second, our setting time tends to be between 3 to 5 minutes, which is quite quick. But you have to understand, as I said, that this can be easily modified using additives. We use retarders and accelerants in order to customize it for the project that we are doing. It depends on how long is the project, how complex is the project. And if you check our compressive strength, tensile bond strength, and flexural strength, you can see that the samples that we have tested, they get a very quick strength. For example, for the compressive strength, in 5 hours we have 20 newtons per millimeter square, or MPAs, which is quite quick. But then it hits like it starts increasing more slowly, and this is what we are looking for, because at the beginning it has to get a really quite good strength in order to support the other layers, and you can tell by the results that we have in our samples. So, for example, when we do projects here in the Netherlands, we usually provide a ready mix mortar. But when we are producing the material in other countries, we have another protocol that we're gonna explain later. But normally, already mix, it has the aggregate, the additives, and the cement that we use. Also, as I said, we use a retarder, and also I think it's worth mentioning that there are many types of retarder. There are solid retarders, powder retarders, but we have chosen to use a liquid one, and it depends, as I said, depending on how much we want the working time, and then we can customize it depending, and also depends on the environment.
Yeah, and so for a small model, for example, you have a very short pad length, so the time between one layer stacking on the other is a lot shorter. So then you use less retarder to make sure that it sets as quickly as possible. If your model is bigger, then the time between the one layer getting on top of the other is longer, and then you use a bit more retarder to make sure that the wet on wet connection is always in the right window where you want it. Also, like Paulo said, depending on environment, if it's very warm, then water will evaporate quicker, so the material dries quicker, so you use more retarder. If it's very cold, it doesn't cure as fast, so you use a bit less just retarder.
Right? Yeah, it depends on there are many factors that you have to take into account. For also the machine that you are using. You're using a gantry, you're using a RC. So it depends. And we usually supply this in 30 kilo cans. So now that you know our materials, we usually have the CyBe ready mix, the water, and the retarder. And the mixer system that we use normally, like I said this normally, but it depends on the client. We have the left mixing pump system is the one that we use when we use 25-kilo bags of cement or the ready mix, and the one on the right is the one that we use when we use the bulk bag of 1 ton. So it depends on the client in order to choose this. Also, I think sometimes it seems obvious to say, but we try to keep the people working around the cement quite safe. So depending on the project that we are doing, we also use IBC tanks that they provide a constant pressure. Normally, we go from 4 to 8 bars, but we prefer to work with 6 bars for the pressure of the water because it's important to have a constant pressure along the project.
Yeah, so that's the water that flows through the mix pump station
Yes.
where it gets mixed, right? It's important that this is constant because fluctuations in water pressure can also cause fluctuations in material quality, which will show up in your print. So
Exactly.
this is why we have this buffer tank
Mhm.
and a separate water pump to make sure that that's nice and stable.
Also, the temperature of the water is quite important. That's why we have a cooling or heating unit.
Yep.
Also, as I said, it's quite dangerous to work with cement because it's such a fine material. So we usually recommend to use the safe and safety equipment, of course, but also a dust extraction.
Yep.
So the way that we print, the process of mixing to print, just to put you in perspective, at the beginning we start the machine. At the beginning, the mix has a lot of water. It has a high level of water, a high level of retardant. And we do this in order to give a little bit of lubricant around the hose, around the tube, the pump. So we avoid any kind of friction when we start printing. So once we lubricate everything, we start decreasing the water, we start decreasing the retarder in order to find our perfect mix, depending on the environmental conditions, depending on everything. We continue testing with how much of retarder we have to put, how much of water we have to put. If you have a lot of experience in a certain place, you can do this quite quickly. It just depends. It's super important to keep your statistics right. So once you test, you know how much water you need, you know how much retarder you need for your specific case, so it's gonna be fine.
Yep.
Then we have the printing. We start printing, and during the printing, after a couple of layers, we start curing because you can see in some of the videos that when we are printing, there is some evaporation of water. So to avoid any kind of cracks for shrinkage or anything like that, we cure during the printing. And then for the shutting down, when we finish printing, we rise again the water and the retarder level to clean everything, to flush everything. We can't leave any kind of residual of concrete inside the machine, so it's ready for the next print.
Yeah, so we start with a very watery mixture, and then we adjust it down to a nice and printable mixture. Then while we are printing, we cool the material because it gets quite warm. While it's cool, we cool it with water against cracking, and then when we shut down, we turn up the water, make it a nice lubricant blubbery mixture again to clean everything out, and then the print is done.
Yep.
Right?
Mhm.
Right.
So now we're going to move to the local material development process that we usually do. And as I said, this depends a lot on the country or on the place that we're going to print. But before that, I'm not going to steal this time the poll.
Uh-oh, now you got me by surprise because I thought you were going to do it. No, I'm just kidding. I'm just kidding. So Paolo is going to tell you something about local material development, but we are quite curious what you guys think are the benefits to doing this, developing the material locally. So let us know. I think.
In the meantime, we have an interesting question from Dennis from Holiday saying like, what's the highest height that you can be built without reinforcement? Do we?
Well, depending on the purpose, right? So if we have a element that it won't get high loads, we can do it quite high, but it depends on the purpose.
Exactly, and it would also depend on what you mean. I think I know what you mean. You would probably mean at what height will the bottom layer not be able to support the weight of the model anymore. I think that would make sense. And if you have, it would depend on the model itself, of course. But due to the quick curing time of our material, we can um, pretty much do this infinitely high, because at the time that you get to a certain height where the weight is too much for the bottom layer has cured so far that it can carry that weight. Of course, if you're going to start very narrow and build a very big object above it, this might be an exception. But depending on the model, we can pretty much do this right to the top.
Also, we are limited by the length of the
Yeah, of course, the
arm.
print reach of the robot. We can go with a very small object all the way from the ground up to the highest limit of our robot, which is with the automatic height extension is around 4.2 meters. We can go do that in one go without the bottom layer collapsing, which is one of the reasons that we can print these elements so quickly, because we don't have to do it in segments. We can go at 500 meters a second, full go all the way to the top. I hope that answers your question. I hope I interpreted the question how you meant it.
The answer on the poll, we have a lot of answers. Costing, knowledge of performance of materials, availability, carbon footprint, environmental credentials. What's correct said?
Okay, so now there are really good questions, answers. Sorry, so we can move to the ones that I thought that they can be the benefits of developing the material locally. And I believe that availability, accessibility, the economic benefits, the environmental impact, and the cultural relevance. In my experience, I can tell that in availability and accessibility, we have to think that normally our concrete is 30% the cement and the 70% aggregate. So normally we try to get the aggregate from the local community. So it's like if we have the material there, why would we bring or export the material from the Netherlands? It's like bringing tulips to the Netherlands. You don't do that. So in this way, we reduce even the price, the total price of the project, and also avoid to have supply chain problems. And we can even reduce we try to reduce as much as possible the material that we send. One of the economical benefits, as I said, like is already not to send the aggregates. Also, when we are using local companies to provide us with the aggregates, this dynamize the local communities, making local businesses to get also involved into these new technology projects. In terms of environmental impact, I think during throughout this whole presentation, we have mentioned what are the environmental impacts of reducing waste, reducing transportation with developing locally. Also, the cement that we use is CSA, so it provides the production of CSA is produces less CO2 than normal Portland cement. One that I really like is the cultural relevance when that allows communities to get involved into projects, because this creates a stronger and more resilient communities. And also when we try to preserve the traditional building practices, because for example, in a community where the majority of the buildings use stone, timber, and concrete, we try to that's also involved the architectural part in order to make a house or a building that goes with the environment, so it can keep the cultural heritage of that community.
Yep.
So when we, as I said, when we produce the material locally, we tend to take the aggregate locally, but also if we have some of the cement providers, we can also take from that. So when we call the CyBe power pack, we are calling the additives with the cement, and that together with the local aggregate creates the ready mix as already mentioned before.
Yeah. So the power pack is 30%, which we call magic soup or power
Exactly.
pack, and then 70% of the mixture is aggregates, and those can be sourced locally. Right.
So just to give you, if you are curious about what is the normal process that we follow with our client, the normal protocol. And before explaining this, I want to mention that this depends on the country, of course, and we always try to find the most efficient way to provide the material. So first, we find a local partner that can provide the aggregate and also the mixing facilities when the client doesn't have this. This local partner has to satisfy the quality standard that CyBe has. So we do a quality assurance. We ask to see the facilities and everything. Then this partner share with us the sieve analysis to see what is the distribution of the aggregate that they are planning to use. As I said, that's the maximum that we use is 3 millimeters. Then if the uh, if everything goes well until this point, we ask the client to send a small proportion of 10 kilos of aggregate for us so we can check in our laboratories. And then the fifth step is the print test. So we ask for a little bit more, a larger proportion of material so we can actually test, so we can guarantee you that you're going to have a successful print. So if you check, this is the sieve curve. This is the curve that we usually ask for the aggregate. And as you can say, is there is some tolerance. Again, I just want to mention that a lot depends on each country. So don't take this for granted. We can make many solutions. I love the part of being an engineer and saying everything is possible. It just needs more thought and more work towards it.
Yep. Everything is possible. The question is,
How
um,
expensive?
how hard is it going to be?
Yeah.
What will it cost, and how much time is it going to take? But we've worked with materials from, like I said earlier, all over the world, and there's always a material that can be found that works, or an aggregate that can be found that works with our mixture.
I've had an interesting question in the chat from Muhammad. He's saying, do you recommend this technology to build a house in seismic zones?
Seismic zones, yes. Yes. Why do we recommend this? Because what we said earlier about the structural parts of our buildings. So, as a structural engineer, what Pablo does, if he's designing a building, he takes into account wind load, seismic loads, all kinds of loads, and based on that, he can determine the reinforced concrete columns and beams. Using this technology, you can easily adjust the lost formwork that we explained earlier to make that bigger or smaller to accommodate this different column size. This also means that, let's say you are planning to build up multiple stories or different weights in the roof, that you can easily change the one column to be a bit bigger and then another part of the building be a bit smaller without changing any formwork. Right, so it's more adaptable.
So now, the first of all, we usually focus on the local code for each building in order to build any kind of seismic construction. So it depends a lot on the local code, and also at the moment, as we said, we just print the formwork and then we put traditional concrete when we try to do structural pieces.
Yep.
But at the moment, we don't build for seismic. Is gonna come in the future, I hope.
Well, we don't really have to take seismic into account in the Netherlands, but
Yeah,
for
exactly.
example, we have 4 printers that are placed in Japan, where seismic loads are, of course, extremely important, as well as New Zealand, where with Korox, who just finished his kindergarten, where I believe seismic loads are also quite a important part of these calculations. So yes, this technology can definitely be used in seismic zones. So Pablo just explained a little bit about this local material development program. And I hear you think that might take a long time. And what is the first time that you test it? And how does that go? And have you done it before? Yes, we have done that before. So this is our partner in Curacao, which is, for those that, of you that don't know, is in the Caribbean. The reason that it sounds very Dutch, Betonindustrie Brievenrad, is because, of course, the Caribbean are the Dutch-speaking islands, or at least a couple of them in the Caribbean are. So this is a project that we did a while ago in the Caribbean, and this is, of course, the first 3D printed building in Willemstad in the Caribbean as well. And the important part about this specific case study is the next slide, if yes, you can take us there. Because, of course, when you get there, when the printer first arrives, let's say you're a customer and you bought a printer of ours, and immediately after this printer arrives, you want to start making money using it. So you want to start on your project. And what you see on the right is how that would look if you would go through local material development. So the first day that the printer gets there, we can unload it and we can install it on the build site or in your factory. That takes somewhere around a day. Printing the second and the third day, we'll start printing with the CyBe ready mix. So this is the material that we brought from the Netherlands or from Europe, which is ready to go. And we use this material to, first of all, test the machine, make sure nothing broke during transport, but also to show your team that will be using the printer what the material is supposed to look like. So we can test our machine and show you that it works. Then we can show you what the print is supposed to look like and what to look at during printing. And then on the fourth and the fifth day, the second and the third day, our material expert that came with you with the printer is now working with your local partner who will be mixing the local mixture to get the material on site. Then fourth day and the fifth day, we will start testing this material, which is also something that we ourselves, the CyBe team, will do for you, because of course we have the experience to do these tests. Then the 6th day till the 10th day, the training will start, which is always included in the purchase of a printer. Makes sense. If you're going to use it, you might as well know how to do that. So the 6th day up until the 10th day will be training you and printing with this material. And then the 11th till the 15th day, we actually started printing on this project. So that means that in 15 days, so 3 working weeks, we did the test. We installed the printer, we tested the printer, made sure that everything was okay. We showed what the material is supposed to look like. We tested the material that we developed locally. We trained you, and we started on this project, all in 3 working weeks, which is, of course, super efficient because you don't want to have your printer waiting around when you get it. You want it to get to work and make sure that it starts earning you money. So this is a very nice and fast process.
I think good to mention is that the preparation is really important.
Yeah,
So,
of course. It's not like on the 2nd and the 3rd day, a material specialist will go to a local concrete factory and say, can you mix this? And then a day after that will work. A lot of preparation goes into this. Of course, while the machine is being made for you, parallel to that, we will be working with you and local partners to make sure that all of this is ready for when the printer arrives. So, like I said, preparation is key, but it's not the first time that we've done that. So, I believe that was pretty much it from our end. I saw quite a lot of questions. I didn't get to answer all of them. I don't know if you guys have any questions about what you heard today. Please let me know, and we can see if either me or Pablo can answer it for you.
For example, the question from François.
Yeah, that's a very good one. And
I think it's important. At the moment, we are working with a partner for developing these geopolymers. So if you are subscribed to a newsletter, you're gonna be the first one to know about this development whenever it's ready.
Yeah. Detailed description of advantages in construction, aiming for ecological transition. Yeah. So there's quite a lot to be found on geopolymers in general. And depending on what kind of material you compare it with, or what kind of geopolymer, or what production method of geopolymer, there are different advantages and disadvantages. Francois, I know we have been in touch, so we can definitely continue our conversation about that in a bit more detail. But there's also quite a lot of information to be found online. And as we are still in the research phase ourselves and working in a bit further phase with our partner, we are still establishing what kind of advantages and disadvantages are important or not so important for us and for 3D printing specifically. In this case, the production has been offsite. Correct. In the Caribbean, we printed offsite, or our partner, printed offsite in a facility, and then moved the elements to the construction site and put everything together there, which makes it a bit easier and a bit faster. On-site printing can be done, but the calibration of the printer takes a little bit more time if you're on-site than in a controlled environment. So for efficiency's sake, we like the off-site concept. But of course, if you want to print on-site, then that's definitely possible. We are currently working in a project on our own project in Florida, out of CyBe Construction, Florida, where we actually do a semi on-site, which means that the printer does print on the construction site, but it doesn't print the elements where they are going to end up. So we print on the site, and then we move them from the printer area to the eventual place that they will end up in the building.
Dinesh asked what kind of concrete we use for building a coral reef. So those reefs actually were printed with our CyBe mortar, the normal CyBe mortar. Of course, we also use additives and admixtures in order to make the durability of the concrete more resistant to be in salt water.
You can also mention our client Seaboost in France.
Yep.
So we did some project and we printed it ourselves. And afterwards, after the project itself, we made a cost calculation, and they want to print that many amount of elements that they now have bought their own printer themselves.
Yep.
Which will be shipped to France to print there locally.
Yeah, which is great, of course.
Francois also is asking about the geopolymer can be developed. Yes, we encourage our clients to develop their own materials also, but you have to take into account that the printer, the CyBe printer, is optimized for the material that we use. But it's of course possible that you can develop your own material, your own geopolymer. So we are happy to support with that.
Like Pablo said, you definitely are allowed to use any material that you would like in our machines. We encourage it. We would actually like to work with you in some cases to develop this. And then the only thing that we expect is that you send a sample so we can test it. And then we can give you okay, this is safe. There's not big fat rocks in there that will break everything. So we will test it to see if it's safe. And then when we give the okay, you will of course keep your warranty for the machine and you can use that material. I saw another question from Mohammed. If we depend on load-bearing wall systems without columns, without reinforcements, what kind of foundation do you use in this technology? And in this case, is it possible to build in a seismic zone? The answer is yes. Of course, it is possible, but the question will be if it's going to be financially viable. And the local regulation, for example, in the Netherlands, we build a building which is called the Vergaderfabriek without this reinforcement. What we had to do for that is every different element that we printed, we had to test it to see if it was strong enough. So you can do it, but you have to test every element. Eventually, it turned out that when we did those tests, we broke the testing equipment instead of our walls, which was great for us, not so great for the one that tested it. So in general, they are strong enough, but in able to get your permit and be in line with local building regulations, it's quite hard to make to do this without this reinforcement. Foundation-wise, I think maybe Paolo
for
can tell us.
foundations, it just depends on the type of building that we are doing. If we have one floor, 2 floors, and also the complexity, so it just depends.
Yeah. So it depends on the ground that you build on.
Exactly, it
location.
depends also on the soil. For Does country system waste more material? As I said, it depends. It depends a lot if you have your statistics right. If you can get your perfect material in a reduced time, it's not gonna waste more time.
Well, the gantry might use a little waste a little bit more material because the hose from the mix and pump
It's larger,
station
yes.
to the nozzle is a bit longer. So that means that if you make a change at the mix pump station, there is a delay until you see this change in material. So the setup time takes a little bit, can take a little bit longer, and of course you lose a bit more material in the hose. It's not a massive difference, but it is a difference.
Yeah,
So
which is
if we're going to be very accurate, yes, there is a difference, but it's not massive. Yes, Dinesh, indeed, 3DCP walls, in our case, act as lost formwork. After printing, you guys fill the middle portion with concrete. Well, not the entire wall, but we print, maybe you can go back to that slide. I believe it was slide 11, quite far back, so stick with us.
and also this just for structural elements. If the element is not to be structural, we just don't do that.
Let's see. Yeah.
This one. This one.
Yeah, further back a little bit.
This one.
There we go. That's the one. So, as you can see here, so there's a lot of empty space. This is still the inside wall, right? This is made for shape. This is infill. But here we have a bit to the left. Yeah, I was trying to do it with my own mouse, but of course only Yes's mouse is shown. So that's the part that we will fill. So not the entire wall, of course, but the part where the rebar is visible, that's what we will completely fill with the concrete. I believe we didn't miss anyone. Korala, yeah, work in India. For more details like that, just if you could get in touch with us, I'm more than happy to speak with you about it a little bit more in depth. Yeah. So Richard saw a little bit about our project in Florida. That's great to hear, Richard. And Richard then probably also saw what can go wrong in the beginning, because with the Florida project we had some newer material, which for some reason there was some straw found in it, which messed with the mix and pump station, which is now of course solved and done. But testing with new material comes with its challenges, of course, but that's what our experience is for. Let's see. Thanks for explaining. Yeah. Kindly share your LinkedIn. I would, but mine is so dramatically outdated that it looks like I'm still in high school, which is a very bad thing for someone in sales. I'm sorry. So you can find me on LinkedIn just using my name, but it looks like I'm still a college student. I believe that's the last time I updated it, which is very, very bad. I will get on that. I looking in Egypt. Of course, we would love to be in Egypt as well. Yeah, please get in touch and we can talk about that. What else do you check? We test local materials. What else do we?
At the moment, when you send this, that's the first step to send the sieve analysis, and then we go further. What after we check the analysis?
Probably so the size of the aggregate,
Yeah.
and probably after that the roughness as well, which is another. But that's something. In a
Yeah,
later
I mean,
stage,
yeah, for the first part, just this.
See. All right, perfect. That's pretty much it from us, and we'll wrap it up there. Like we say every time, if you have more questions, you can always reach out to us via our contact form. We also have our courses on the academy, which is super interesting, and a lot of information that we tell about here is offered there in a course. So it's even more interactive, and you can learn about it yourself. That's on our academy. And then our library, of course, is our collection of models, where we recently placed some new models, as well as, I believe, robust villa, the case that we talked about might actually be, is probably on there as well. So buildings like that we've done in the past are also available there.
I can give you I can show it right now.
Well, you don't have to show it; they can find it themselves. That's why they should go to the link for our library, of course. So what we always do at the end is ask for a evaluation. So you will get a link to a little evaluation form, which we would love if you could fill in just for our own reflection, so that we can go to bed happy tonight, or sad, depending on how you guys thought it went. So reaching out to us can happen via sales@cybe.eu or support@cybe.eu. However, if you do want to get the quickest response, I would really press to use the contact form where you fill in a little bit of information, because that immediately gets to me, the sales inbox as well, but that can become a bit messy with spam problems and stuff like that. So the contact form would be brilliant, and I'll get back to you as soon as possible. Thank you guys again for sticking around so long, and I hope to see you the next time.
Yes, thank you all. Bye bye.
Bye bye.